Alright, so to continue what we were doing before I got cut off by my encoder, I was trying to show you that basically you share electrons when it comes to nonmetals. And here we have a perfect example of that with water. Water has it is H2O, right? And it exists with one electron in its valence shell. Two, the first shell usually can only hold four. It can only hold two, right? And so what hydrogen needs is that extra electron from oxygen to complete its octet. So the first shell can only hold four, whereas the second shell can hold eight, right? So here we have hydrogen is going to bond with the oxygen here, and it will bond again here. So not only has hydrogen achieved its octet, so has oxygen. It has 1, 2, 3, 4, 5, 6, 7, 8, right? Where hydrogen has 2 in its outer octet, which is the first shell. Now, covalency lends to shape, right? So with this, these two sets of electron pairs, you have two pairs, and we call those lone pairs. And you would usually draw some balloons over them, to represent the electron density in here. So this is our electron density. These pairs here, the sharing pairs or the bonding pairs, you would draw them as straight lines. And it lends the shape of this as being bent. So this will push down on the bonding pair there, and this lone pair also push down on the bonding pair there. And in between here, the repulsion that's existing is greater than this repulsion. That is why you push down and squeeze it, and we would have the shape called bent. Now it's the same thing when it comes to carbon bonding with hydrogen. Carbon has 4 electrons in its valence shell. Hydrogen here again has only 1. So how many hydrogens do you think carbon would need to bond with it? Exactly 4. So you would need 4 hydrogens to bond with the carbon. And of course, I want to put some color to it. So you would have one going here, one going here, one going here, and the other one going here to form bonds, and they will eventually form something like this. Meaning that everything will achieve its octet and be happy. And this shows that you have no bonding, no lone pairs. You have 4 bonding pairs and no lone pairs at all. All these are bonding pairs. So therefore you would have this shape where you would have um, that, that. This will lend to the shape called tetrahedral. Right? In truth, it would be like 2 fingers, your index finger and your third finger sticking up, and your other hand trying to do the same thing, but on the other side like that. So you would have this and this in the middle, front and back, and this on the sides like that. And that is a wrap. So tetrahedral shape. Let me know if you need any help with more bonding and ionic structures with covalency, and I'll be sure to help you. Don't hesitate. Okay? That's a wrap.